So, Rainer, have fun. Thank you very much, Conny.
Thank you, Hans Christian. Can you give me a quick feedback whether you can hear me loud and clear?
Everything looks great.
Everything looks great. Okay, thank you. Thank you very much. Yeah, thank you for having me. Thank you for giving me the opportunity to introduce you to a completely different approach of building front-end applications for the browser. In the next, let's say, 40 minutes or so, we are going to talk about WebAssembly and a framework that Microsoft introduced recently, which is called Blazor. And I would like to start with a few slides here, but afterwards I will jump right into Visual Studio and show you lots of code and demos and so on. I would like to start by giving you a quick, let's say, personal introduction to my view on Blazor, why I got excited and why I'm using Blazor here and there. You see, I'm old. I started professional development, I would say, more than 25 years ago, when I grew up with C++. That was way before browser apps became very popular, and when I recognized C# and .NET, I immediately fell in love. I did never really touch Java. Why? I don't know. It just happened. It just happened that I fell in love with C# and did a lot of work, and I did a lot of client development, server-side web development. I loved that stuff. But when it came to the browser, I had to use different tools. Okay. I have to admit, I did the usual mistake. I was young, I was stupid, I needed the money, so I tried Silverlight to bring C# into the browser, but that didn't play out very well, as we all know, so forget this one. So I undusted my rusty JavaScript skills many years ago, and I learned to like JavaScript, especially when TypeScript came out. So I developed a lot of solutions with JavaScript, with TypeScript. I have used and I have been using still in my own company Angular, Node.js and all these stuffs. I really love this stuff. But you know what? For me personally, it has a certain value to have the same language on the server side and on the client side. Code sharing is a thing. And the thing is, for backend development nowadays, I really like C# and .NET. It's nowadays completely platform independent. It works really nicely, like a charm in Docker container environments. It works on Linux, on macOS, on Windows, whatever you would like to use. It works really nice. So, yeah, I love JavaScript, I love TypeScript, I love Angular, but still I would like to break the monopoly of JavaScript in the browser. And now entering WebAssembly. For those of you who are not that familiar with the WebAssembly standard, WebAssembly is essentially a binary instruction format on a stack-based virtual machine. Most people know WebAssembly from running non-JavaScript apps in the browser, but essentially WebAssembly is really a kind of assembler, low-level assembler language for any kind of app that is downloaded over the internet. It can run inside a browser. Nowadays, to be honest, most WebAssembly applications run inside the browser, but it doesn't need to. It could also run outside the browser. It could be a server application, but this is out of scope for today's workshop or for today's session. Well, the native languages for WebAssemblies are low-level languages like C, C++, Rust, and so on. Of course, they can be compiled to WebAssembly, and with that, the monopoly of JavaScript was broken, because now we can run any kind of code that is built somehow on the C, C++ family of languages. In contrast to my good old friend Silverlight, this runs on an open standard without any plugins. And why should you use it? Well, it's fast, it's safe, and it's not JavaScript. Okay, for those of you who love JavaScript, that is not a very good argument, but for me, as somebody who also loves to write C#, it is a kind of important thing. Now, what about the common language runtime? For those who are not familiar with .NET, the common language runtime is the runtime below .NET, which is nowadays completely platform independent, runs on all operating systems, and comes in various flavors. What is the story of the common language runtime in WebAssembly? Well, story is simple. C++ can be compiled to WebAssembly. The .NET Common Language Runtime is written in C++. So why not take the Common Language Runtime and bring C# with WebAssembly into the browser? Well, somebody did that. I think it was in 2017, the Mono team. Maybe you have heard from the Mono team. It was originally an open source flavor of .NET. Nowadays, everything is in .NET because Microsoft made years ago .NET and C# completely open source. But there is still this Mono team. And what they did is they took the common language runtime, compiled it because it's written in C++, and ran it on the WebAssembly runtime, and suddenly we had C# running in the browser. Well, it wasn't that easy, granted, but it worked. The preview was there. But to be honest, WebAssembly is very, very limited. You can't do a lot of interesting stuff with WebAssembly. You can just manipulate some bits and bytes in memory. You have very limited or no interaction with the DOM and things like that. So you need a kind of more higher level framework. And this is where the Blazor framework came into place. You know, for those of you who are not that familiar with Windows, and Windows development and the .NET ecosystem, there is a language, a template language for web development with C#, which is called Razor. And Blazor is Razor for the browser. This is why it's called Blazor. It is built on the .NET Mono runtime, yes. It uses the Razor template syntax. You're going to see a little bit of code later on. And finally, the whole behavior of your app is written in the .NET Core and the C# that you know and many of us love. And this is what Blazor is all about. Blazor is more than just WebAssembly. Blazor is a fully featured single-page app framework. You see, I will not go through this list. I will just keep it on the screen for a second so you can check all your personal boxes. Yes, you have support for PWAs. Yes, you have logging. You have a client-side router. You have a powerful template engine. You have CSS isolation. You have a UI component system. You can do data binding, event handling. You have third-party vendors and built-in UI components. You have layouts. You have JavaScript interop. A lot of the stuff that you demand from a single page app framework, and everything is built on top of WebAssembly. It has to be, because otherwise we couldn't run C# inside of the browser. Good, and with that we jump right into demos. Okay, so here let me quickly restart my cam. I just saw that the camera was not in front anymore, so now you can see my code and my face, see me talking while I'm going to present. I would like to do a two-step demo here, okay? I would like to show you a brand new Blazor app, and we will kind of take a look in the anatomy of this Blazor app. We will take a look how C# is compiled to WebAssembly, how large this stuff is, how it works with HTML and all this stuff. And once we have understood the general principles of a Blazor WebAssembly app, I will switch gears and switch to a different application, which I pre-built for you. You will find the link to the whole application in my slide deck. It's on GitHub. Take it, play with it, do whatever you want with it. And this is a much larger application which shows more interesting features, and we'll see how fast I will go through all this stuff and how much time we can spend with this sample. You see, I'm using here, yes, I'm using Windows nowadays, but believe me, I have a bash here too. So, sorry, this is not the, I can't always run an Ubuntu bash, for instance. So even if you hear somebody nowadays say he or she is running Windows, Ubuntu, Debian, and so on, it's always built into Windows. So personally, I switch between Windows and Linux whenever I need, because Windows has something which is called the Windows Subsystem for Linux, which allows me to run Linux, the Linux kernel, directly inside of Windows, and I have best of both worlds. However, for this demo, because I have so limited time, I'm going to use Visual Studio, the fully blown Visual Studio. There is a free community edition of Visual Studio, so you can do all the things that I show you for free for your study, for instance. But if you want to have everything open source, not just the framework, the compiler, the languages, if you want everything open source, even the IDE, you should do this demo using Visual Studio Code, which is the open source cross-platform HTML JavaScript based editor that you probably know from other development stuff. But Visual Studio has a bunch of nice productivity features which make it easier for me to do this quick demo. So yeah, I hope you are not mad with me when I use here Visual Studio. So you see, the first thing that we will see here is that we can build a Blazor WebAssembly app and we can build a Blazor server app. Well, that sounds interesting, both of these things. Keep that in mind. We will now focus on WebAssembly, but I will talk about a few minutes on server apps too. Good. Let's say create, and I'm building a new Blazor app from scratch. It's completely new, and here we are. This is a Blazor app, and as you can see here, program.cs, okay, that is C#. And if I take a look here, for instance, in such an application, yes, and now it becomes interesting. This is an HTML template with the Razor syntax in it, and down here you see C# code. And this is what Blazor is really all about. It's an HTML-based UI framework with all the things that you expect, like client-side router, data binding, event handling, and so on, mixed with logic written in C#. If you don't like having the view layer and the code layer in the same file, well, that's absolutely no problem. Of course, you can very simply take the C# code and put it in a separate file, so you have HTML and C# nicely separated. For demo purposes, I like doing both in a single file, so you always see both things. Here, for instance, you see a really nice, very, very basic example. Here you see an interpolation, a kind of one-way data binding, and down here you see a property, or in C# it's called a field, and you see it's bound here to this property, and we can here have an event handler, and this event handler is calling into a C# function which will run inside the browser. So this is essentially how you program. Of course, I could spend days just talking about the features of the templating engine and all this stuff, but I only have half an hour, so I will just run this guy here. I will not use Internet Information Server. I will just use the command line. This runs on Linux, this runs on Windows, this runs on Mac, whatever you want to do. So here we have our Blazor app running in the browser. This, on the left-hand side, is HTML backed by Blazor and WebAssembly. And the first thing that you probably want to know is, where's WebAssembly? I want to see that. Let's take a look at the counter. You see here, that's just HTML, nothing special. That is not the kind of Silverlight that you maybe know from former times. But where is WebAssembly? How is WebAssembly used for this single page app framework? Well, let's take a look first in the applications and clear the whole caching here so that we really see what's going on behind the scenes. So let's preserve the log, let's disable caching, and then let's hit refresh. And now you see the good and the bad things of this framework. The first thing is, if I scroll up here a little bit, you see a bunch of classical things being loaded. Some kind of HTML stuff and some kind of CSS and JavaScript, and I'm using Bootstrap here for this very simple demo. And this one is the JavaScript part of Blazor, okay? Yes, there is a JavaScript part because from WebAssembly you cannot directly talk to the DOM, so therefore there needs to be a small tiny layer of JavaScript. But then it's getting really interesting, because if I scroll down at the nearly very bottom, let me see where I can find it. Here is it. At the very bottom you see a WebAssembly file. This is the .NET framework, the entire .NET framework. This is the same .NET framework that you run on your desktop, on Windows, on Linux, in your Docker container. That's the .NET CLR compiled to WebAssembly running inside the browser. And the rest of the stuff up here, it's DLLs. This is C# DLLs. That's binary compatible DLLs, and you can use exactly the same DLL on your client app, on your server app, on Linux, on Mac, on Windows, and now inside the browser. So what we get here is we get the full feature set of .NET. But of course, many of you now immediately say, Rainer, are you serious? 24.2 megabyte for a Hello World Blazor application? Well, I have two answers for that. No, let's say three. The first answer is, if I reload this stuff, let me remove the preserved log here. The whole WebAssembly stuff is not loaded anymore. The JavaScript part caches the whole .NET framework, so the performance penalty only hits a customer once. Once the customer has downloaded the .NET framework and everything inside the cache, everything is okay. That's the first answer. Second answer, C# has a linker, and this linker can reduce the size of the DLLs significantly by removing all the stuff that is not needed. In Angular, this would be called tree shaking. It's exactly the same concept applied to C#. And with that, we can reduce the size of this application to, let's say, 2-3 megabytes something. Still, 2 to 3 megabytes is huge compared to a framework like Angular with production build enabled, for instance. And that is a very important message that I have to give you. Don't use Blazor if you want to use the smallest possible web application with the smallest possible footprint that loads blazingly fast on even slow network connections. This is not the sweet spot of Blazor. Imagine that you work in an enterprise. This enterprise has decades of history of software development. Many, many years ago, this enterprise decided to go for .NET because it's a very robust infrastructure. It is enterprise ready. Lots of code exists, a very large third-party ecosystem. You decided to go C# many years ago. You have a lot of developers knowing C#. You have a lot of business logic written in C# in your enterprise. And now you would like to conquer the browser. If you are in the business-to-business area, maybe you don't care whether your web application is 500K or 3 megabytes. Maybe it doesn't matter because you are on a LAN, you are on LTE, you are on a strong network, and with the caching in place, you only have to pay the performance penalty once. In such scenarios, Blazor, WebAssembly, and the CLR are really, really interesting because you do not have to retrain your whole development team. You can use existing code. You can use existing DLLs, NuGet packages, and so on. So the productivity of moving towards the browser is enormous. And that's the point. That is why Blazor is so interesting for many enterprises out there who have a strong background in C# development, or even have a strong background in a different language which is not JavaScript. Because to be honest, if you are super happy with JavaScript and TypeScript and you love Angular or React or Vue, why should you switch to Blazor? I don't have a reason for you. You will probably not. But if you are new to this whole ecosystem and you are used to languages like C#, Java, and so on, then a platform like C# gives you a lot of features that JavaScript simply can't. Show a C# developer a node modules folder and he will run away shouting and tearing his hair because they are not used to that stuff. Okay, we as JavaScript developers, we have learned to accept that, but they don't. And you don't have this stuff if you use Blazor, for instance. Okay, now let me quickly move to my second demo. Let's see here. Let me quickly start the backend. Okay, this is the backend stuff. This is just a web API, a REST API that I'm going to use for this demo. And let me quickly show you this demo, show you what this stuff does. I will switch to here, the Blazor client, and run it. Now this application is a Starship Traveler application. So it's a fictitious travel agency where you can book trips. For instance, here, Mr. Bumblebee booked a trip from Cybertron to Earth, for instance. As you can see up here, you see the client-side router. If I go back, you have some UI encapsulation. You can build UI components like this switcher here. You can build UI components like this QR code. You can even embed things like SVG. I played a little bit with SVG and built this whole graph with an algorithmic way. So I used C# to build a little bit of math to calculate the SVG. So you see SVG support is here inside the box, and I will show you later on what this stuff is all about. And I can also talk to backend services, for instance. So let's let Luke Skywalker travel from, let's say, where is Luke Skywalker? From Tatooine, and let's travel him to, I think it was Vulcan. Of course this, no, let's talk from Cybertron to Vulcan. Let's take this one. And please note this message here. It says, I'm very sorry, there is no direct connections from Vulcan to Cybertron. You have to travel from Vulcan to Tatooine, from Tatooine to Krypton, from Krypton to Earth, and from Earth to Cybertron. So, this was the demo. Okay, now you have seen the beautiful app, and let me now spend only a few minutes showing you how this is done and why Blazor is really unique for an application like that. First, you see here, this is the Blazor app. This is the Blazor app which is compiled to WebAssembly, but if you take a look at the code, there is nearly no code. There is only a little bit of startup code, nothing else. And this is where a platform like C# really plays its strength, because things like class libraries, NuGet packages. NuGet is similar to NPM or Maven or pip. NuGet packages, packaging up stuff like templates, like web stuff like CSS, SAS, images, and so on, like Razor templates. Packaging that into reusable components is something that C# does for decades, and they are super good with that. And you can do that. You can put all your logic. For instance, let's take a look here at the stuff where we saw the ticket list, for instance. This is the implemented ticket list. You see, you have this time selector. Can you remember where I can switch between past tickets and future tickets? This time selector is, again, if I take a look, another component. As you can see, you have some events. You can add some C# code. This is the kind of thing that you can put in a class library easily, and then all you have to do is right click here, add a project reference, and it just works. But the thing that got me when I first saw Blazor was something else. What I did here in this demo, and it's here in the modal DLL here, I went to NuGet.org, which is the website where NuGet packages, where DLLs from third parties are stored, and I looked for a shortest path algorithm like Dijkstra. And you know what? This Dijkstra library was built years ago when there was absolutely no Blazor. This is a really old .NET component which somebody put on NuGet many years ago. Imagine you are working in an enterprise and you have a lot of existing code compiled into DLLs. And the magic here, the thing that showed me the message box that we cannot directly travel from, I think it was Vulcan to Tatooine or something, this was calculated with a Dijkstra algorithm from a DLL, from a NuGet package, which was built years ago when there was no .NET Core, no .NET 5, no Blazor, no nothing. But we can still run it on top of WebAssembly directly in the browser. Yes, it's not the smallest possible web application that you can get, but believe me, for enterprises who have a lot of code base in this area, this is a game changer. This is really a game changer. So you might now ask yourself, how does that work? Let me show you 2 or 3 animations, and then I'm done, and I accept questions if you want. Now, if you have the browser and the web server here, and the user is opening your website, the browser is also, of course, served with HTML, JavaScript, CSS, JPEGs, WASM, DLLs, whatever static content. You don't need .NET on the web server. You have a static web server. You can host Blazor apps on GitHub Pages if you want. And obviously, you can put it in Electron to build desktop apps. Of course, you can do that. It's just static files. Now, the DOM itself uses the Blazor and Mono JavaScript stuff, and this stuff is now talking to the .NET runtime with Blazor and your app, and the left-hand side is now the WebAssembly stuff. And what happens at runtime? At runtime, the Blazor stuff, the JavaScript, initializes your app. It works like that. And then the app can build a logical DOM if you want. And this stuff is now given to JavaScript and is changing the DOM in the browser. If the user clicks a button, you have an event which travels through JavaScript into the mono runtime to your app to .NET Blazor. Oh, sorry. And if you want to talk to backend microservices or backend services in general, let me put that here, you can easily do that by just talking to the web API the way you are used to do that. And it's done via JavaScript, and you can just do it in C#. C# talks to JavaScript, JavaScript talks to your web API. If we dive a little deeper, then this stuff works like that. Your app creates controls the UI. So it uses the Razor template to build a kind of DOM. This is a logical DOM, and this DOM is then packaged up in something which is called a render batch. This render batch is given to Blazor JavaScript, and Blazor JavaScript is then adjusting the DOM in the browser accordingly. If the app changes something, for instance, adds something to the logical DOM tree, then a change render batch only with the changes is sent to Blazor JavaScript and then sent to the DOM. And with that, we are good. Let me close by talking just a few minutes about the different flavor of Blazor. My talk here today was announced as WebAssembly framework, but it wouldn't be complete if I wouldn't tell you what Blazor server-side is, because it's really important for a lot of companies and use cases out there. Let me just rerun the Starship Traveler application again. Oh, it's on the wrong screen. Let me put it here on this screen, and let me show you the network again. Just so we are absolutely sure there is nothing cached here, as you can see, and I will reload my list again. If you take a close look, can you see WebAssembly anywhere here? No, it is not, because this is a unique possibility of Blazor. You can choose to run the entire Blazor stack on the server and just do the rendering on the browser. How does that work? Let me show you that here. You run the entire Blazor stack, including your app, on the server, and of course they are talking to each other. On the browser side, you only have JavaScript. And in the WebAssembly stuff, the JavaScript stuff was talking to WebAssembly. There was also already a kind of marshalling going on between WebAssembly and JavaScript. And what Microsoft did is they just plugged in a different mechanism of communication between JavaScript and Blazor, and they built it on top of WebAssembly, on which another protocol which is called Signalar is sitting on top. So what we essentially have is we send HTML to the browser, forget that one, I will talk to that in a second, and if you build a logical DOM, the render batches are now transferred through WebSockets to the browser, and events are sent through WebSockets back through the so-called circuit to the server-side rendering stuff, to the server-side rendering Blazor, which talks to your app, and your app can act accordingly, and it sends another render batch, and everything is going on and going on. Why should anybody do that if you have WebAssembly? Well, there are a lot of reasons. First reason, old browsers. I personally know some banks and insurance companies which force us to build software on IE11. Yes, I have to admit we have to deal with such stuff. IE11 does not run WebAssembly. This can be run in WebAssembly. But even more important, there are in real-world situations where you don't have the time to build web APIs. What you really want to do is you want to access a database directly from your code behind of your template inside of your Blazor app, because you have to have the best possible developer productivity, because you're building a small department app and your customers only have a very, very limited budget but still want to use a browser app. Is it optimal? No. Is it technically inspiring? No, it isn't. Does it have a lot of problems regarding WebSockets, and does it run over slow network connections? No, it's not the ideal solution. But for some areas, it's really a very good solution. And the good thing with Blazor is that you do not have to implement this stuff twice. You just add a WebAssembly version of your code, you add a server-side version of your code, and then you put all your components in a class library, and this class library is entirely platform independent. It runs on the server with ASP.NET, which can be a Docker container, by the way. We are not bound to Windows anymore. Or it runs directly in the browser, exactly the same code without any changes. So this is what Blazor makes really interesting in my point of view. I added a few extra slides here. If you want to read more, I will share the slide deck, of course. And let me close by showing you this slide and try to bring it to the point. Should you use Blazor? Well, compare it. If you have a strong investment and knowledge in C# and you only have a little bit of knowledge in JavaScript and TypeScript and you don't want to move everything into that direction, Blazor might be interesting. Yes, Blazor is younger, therefore the community isn't that large as with JavaScript and TypeScript. Yes, Blazor is younger, so the tooling still needs improvement. Yes, there are still some features missing. For instance, full SVG support isn't there yet. It's really bleeding edge, or let's say nowadays in 2020 it's leading edge. It's not bleeding edge anymore. It's ready for production use. So if you ask me, if you are a well-skilled web developer, you will probably stick to your JavaScript-based framework. But if you are a C# developer, a Java developer, somebody who don't want to invest from now on a lot in JavaScript and TypeScript, Blazor can be a really interesting option. And for me, it's kind of both worlds. On one day, I enjoy writing Angular apps with TypeScript. On the other day, I enjoy writing web apps with Blazor. It works like a charm, using the right tool for the right job. I hope this gave you a little bit of an idea what Blazor is all about, why it's interesting, why it's maybe not interesting, depends on your use case, and how Blazor is using the WebAssembly standard inside of the browser to bring a different language than JavaScript into your favorite browser. And with that, I am done, and I would like to open it up for questions.
Thanks a lot, Rainer. That was really, really interesting for me, and I really liked how enthusiastic you are. But on the same and really question also, does it all really make sense? We have a question about that in the chat. I'm not sure if maybe your last slide answered it, so let's see. But I myself have a question about what you just showed regarding the server-side part. I was wondering, could you also say I only want to do parts of it on the server side? So for instance, this Dijkstra, do that on the server side, but the rest should be done on the front in the client side. Is that possible?
Well, in that case, you would use ASP.NET Web API on the server side, and you would just take the existing Dijkstra NuGet package, wrap it into a RESTful Web API, for instance, or a gRPC stuff, or whatever you want to do, and then use client-side Blazor and do a REST call or a gRPC web call to the backend and use the library there. That's absolutely supported, and of course, yes, you can do that.
Okay, but it doesn't just magically work.
No, it doesn't just magically work. No, no, that is not the case.
That would have been even more thrilling. One more question that we have. It's a bit longer question. I'm not sure about the parts that are in there. Neil asks if you have any recommendations, recommended resources for learning WebAssembly within .NET. I guess that is on your slides, 2 slides before that, I assume.
If you just to be honest, just Google Blazor, and you will end up on the documentation site of Microsoft ASP.NET Blazor, and they have lots of learning material. Check out YouTube. Microsoft has a lot of material there. I run my own YouTube channel. I have a lot of Blazor stuff there, Blazor workshops, and more talks inspiring you why you should use Blazor and things like that. So I think the docs and YouTube are a great source.
Okay, that's basically what I would have responded to React as well, so I understand your answer. I posted another question into the Zoom chat because I could try to read it out loud, but I'm not sure. I don't understand half of what's written down there.
Let me see.
So maybe you just have a short look and can summarize it and answer it in the same course?
Okay, this one is very simple to answer. I do a lot of .NET for many years, and I have not been using iJS for many years now. If you use .NET and ASP.NET, you don't need iJS anymore. I run my .NET applications mostly inside of Docker containers with some kind of Nginx as a kind of load balancer in front of it, or run it natively in a cloud like Azure or something like this. So Internet Information Server, yes, you can still use it if you are bound to a Windows server, but to be honest, nowadays the cloud is made of a lot of Linux servers and not Windows servers. So no, iJS is absolutely not needed, and it's extremely stable without iJS.
Okay, now I understand the question. Now that you answered it, I got the question. Before I will get back to the last question that's hopefully still open, we had this discussion on developing on Windows or not before. Some people asked that in the chat, and now we actually have 2 people presenting on Windows. So I would like to ask you as the audience, which operating system do you use to develop? I created a poll in, how's it called, in Swapcard. So you should be able to answer it in Swapcard. I guess on the right-hand side where you have the discussion, you can click a button on which operating system you're using to get a feeling on, is it really the case that there are only a few developers doing Windows development? I guess for Rainer, who's coming from the .NET world, a lot of people in your network are probably using Windows. But apparently many JavaScript developers are confused by people using Windows. So I'm really curious about what you folks use out there.
I would like to, let me quickly say something in response, because many people don't know that. In the latest version of Windows, which came out only a few weeks ago, you have something which is called the Windows Subsystem for Linux, and that allows you to run Linux directly on the Windows kernel. So if you ask me, do I use Windows for development? My answer would be no, because I really don't. Yes, I use Windows as my window manager. Yes, I run Visual Studio Code in a Windows process. But everything else, all my development tools, everything runs in Linux, in a Linux kernel, in a real Linux kernel, without Hyper-V, without a virtual machine, natively on Linux. So Windows or Linux, that's not the case anymore. It's Windows and Linux on Windows. That is how I develop.
That's really interesting, and it's a bit different from what I experience on macOS. The last question, you touched it before, but maybe we could still look at it from the words that Justina's used there. In what kind of scenario would you say this project really requires WebAssembly rather than React or Angular or some other front-end framework?
I'm not sure if I got the question correctly. Can you repeat it? Maybe I...
Yeah. So what is the situation where you think you should really go for WebAssembly in a project instead of just using React in the front end?
Ah, okay. Now I understand it. WebAssembly is a misunderstood technology. You cannot compare WebAssembly with React, Vue, or Angular, or whatever. With React, Vue, or Angular are front-end frameworks. You can compare Blazor with Vue or React, and I think I told you when I would use which framework. WebAssembly can be compared to the JavaScript runtime. So when should you use WebAssembly compared to the JavaScript runtime? If you would like to use a language which is not JavaScript. If you have code in C, in C++, in Rust, in C#, as I showed you today, then you need WebAssembly to run this code inside the browser. And why should you use a language other than JavaScript? Well, maybe you don't like JavaScript, but okay, that's a very subjective point. But it's often a matter of which code base do I have. Imagine you are building a CAD, computer-aided graphics application, and you have millions of lines of C or C++ code for business logic, and you would like to run it in the browser. WebAssembly is a good thing. Or the second thing is sometimes performance. Because with WebAssembly, you can do things more efficiently than in JavaScript. For certain applications, this might be also a reason why you look into different languages than JavaScript, and that means WebAssembly. I hope that answered the question.
I guess for me it actually did. I don't know if you folks already looked at the poll. By the way, if you have further questions for Rainer, just post them. But the poll currently looks that 70% of you are using macOS, but 24, so a quarter of the audience here uses Windows. So I think there are really a lot of people coming up that do JavaScript and are moving to Windows. And I guess the reasons that Rainer just brought up with this subsystem is the reason where development with Windows is way more fun than with macOS days, because if I think about big Angular or React applications that are running in Docker containers on a Mac OS system, then we sometimes have a performance problem with Docker there. And I guess that's better on Windows these days, right?
Yeah, Hans Christian, I have another thing. Maybe I can convert you to Windows with that. No, I don't need to. But let me tell you one thing with with the Windows subsystem for Linux, and that it was really a game changer for me. Why I immediately switched to that is then you can run Docker, not only the CLI, but you can run the Docker host on top of a native Linux kernel without needing to run any kind of virtual machine, and that is blazingly fast. So you don't need Hyper-V, nothing like that. You just run the Docker server inside the real Linux kernel directly running on top of Windows, and that performs really good, and that for me was a game changer in my daily development.
I completely understand. I would love to have that on macOS, but yeah, life is not always like that. I think we don't have any more questions. And I guess then we can call it, no, not a day. We can move a bit early to the break. I really want to thank you, Rainer. It was a really great talk.